in this lecture, we are going to discuss about a Newton-Raphson method. As we know that Newton-Raphson method is a non-bracketing method. So, non-bracketing method means the restriction like a bracketing method means find a one point which the value of the function is positive, another point where the value of the function is negative in each iteration. So, this limit means suppose the root lie will be 1000 to 1001, then what will happen in a bisection method? We start from 1, x0 equal to 0, 1, 2, 3 up to 1000. We find the first positive point 1001, we find the negative points. But in case of so what will happen here? Rather than to find out root, here we search a class interval in a significant amount of time. But in a Newton-Raphson method, we start from any arbitrary value under the condition that initial value satisfies the criteria for convergence. Then we proceed then we able to the sequence of iteration able to converge to the actual root. Now we start the Newton-Raphson method. First we describe the geometrical interpretation of a Newton-Raphson method, means how we find, then mathematically we derive the iterative scheme of a Newton-Raphson method, then we solve some numerical example based on a Newton-Raphson method. So, what is the geometrical interpretation of a Newton-Raphson method? Newton-Raphson method. So, short form of a Newton-Raphson method is what? Newton-Raphson NR method. NR method. Newton-Raphson method. So, suppose any function here, suppose this one is the x-axis, this one is the y-axis, and this one is a function, this one is a graph of equation y equal fx, y equal fx, y equal fx. So as we know that this one is not a bracketing method, so we choose any value arbitrary. Suppose this one is the xt, we choose the initial value xt, x0. So what is the condition with x0? X0 satisfies the criteria of convergence. Later on we discuss about the criteria for convergence. What is the criteria for convergence? Means how we choose the value of x0. So what is the coordinate of this point? Coordinate of this point become what? x0 f of x0. x0 f of x0. Now this one is a curve, this one is a function, and this one is a one point. Now we are able to draw a tangent. So if we draw a tangent at this point, draw the tangent at this point, and suppose this one is a point of intersection with x-axis. And this point of intersection with x-axis is what? This point of intersection with x-axis is nothing is first approximate value of our approximate root. So at this point again, we find the value of the function and write a coordinate of this point. This one is x, f of x1, and again draw the tangent at this point. Draw the tangent at this point. So we find the second approximate root. So this one is what? This one is our actual root. This one is alpha. Alpha is our actual root. Alpha is our actual root. And the value of f of alpha obviously equal to 0. So first we find the equation of a tangent, then point of intersection with x-axis, this and the value of x is nothing is the first approximate value. Then again we find the point of the value of a function, and again draw the tangent at this point and find a point of intersection with x-axis. This one is a what? This one is nothing is second approximate root. So you may see this one slowly means as we proceed means as the sequence of iteration x0, x1, x2, x3, x4, we proceed up to xn, then we approach to our actual root alpha, where the value of the function equal to 0. Now how mathematically we derive this one? Mathematically, how we derive this one? So what is the equation of a tangent? The equation of a tangent is a y minus y0 dy by dx is a slope at x0 y0 and x minus x0. And here what is the x0? X0 is x0, and what is the y0? Y0 is f of x0. So here we write y minus f of x0 and dy by dx. Dy by dx, y is a fx, then dy by dx is a f dash x. So this one equal f dash x at x0 y0. So this one equal what? In place of x we write what? x0, because dy by dx at x0 y0. Now this one is a x minus x0. So now this one is the equation of a tangent. This one is the equation of this tangent. This tangent. Now how we find this point? This one is a point of intersection with x-axis. So what is the equation of x-axis? Y equal to 0. So here we put y equal to 0. So if we put y equal to 0, then this one become minus f of x0 equal f dash x0 x minus x0. Now if we simplify this one, x minus x0 equal minus of f of x0 divided by f dash x0. If we simplify more, then this become x equal what? x0 minus f of x0 divided by f dash x0. x0 minus f of x0, and this point of intersection, this value of x, here we denoted this one by the x1. So here we write this one equal what? This value of x equal what? x1. Now in a similar manner, if we find the equation of a tangent at x1 y1, x1 f of x1, so here what is the change in this equation? In place of x0 we write x1, in place of f of x0 we write f of x1. Then x2 become what? x2 become x1 minus f of x1 divided by f dash x1. Now in a similar manner, xn plus 1 equal xn minus f of xn divided by f dash xn. F dash xn. This one is a what? This one is a iterative scheme. This one is a iterative scheme of a Newton-Raphson method. Iterative scheme of a Newton-Raphson method. Xn plus 1 equal xn minus f of xn divided by f dash xn. So this one is a iterative scheme. Now, how we choose the value of x0? Suppose we choose any random value of x0, then what are the possibilities? So here, graphically, we try to examine what are the possibilities if we choose any value. Randomly we choose the value of x0. Suppose the nature of a function is like this one. Nature of a function, this one is the nature of a function is like this one. Suppose here, like this one. Nature of a function is like this one. So, suppose first we choose the value, here we choose the value of x0. Here we choose the value of x0. Initially we choose this value, x0. x0. And if we draw the tangent at this point, then this will intersect. This will intersect on the x-axis at this point. This one is what? This one is the first approximate value. If you find the value of the function at this point, then this become what? X1, f of x1, f of x1. Suppose this one is like this one. So f of x1. So if we draw the tangent here like this one, then this will intersect too far from our actual root. Where is the actual root? Actual root is here, alpha. This one is actual root. So first we choose the x0, then we find the difference between x1 and alpha is larger than difference between x0 to alpha. This means we move far from our actual root. And next one is goes in a negative side. This means we move more far from our actual root. We are unable to converge to our actual root. Now try to think. Suppose this one is a function like this one. This one is a function, and here we choose the first approximate value. Suppose here x0, root is here. This one is alpha. And here if we try to draw the tangent, this one is a what? This one is a parallel to x-axis. This one is a parallel to x-axis, then what will happen? We unable to find out a point of intersection with x-axis. We unable to find out a point of intersection with x-axis, then what will happen? We unable to find out our next approximate root. So there is a need to very precisely to choose the value of x0. So how we choose the correct x0? So that the sequence of iterative values means x0, x1, x2, x3 up to xn plus 1 must be converges to our actual root. So what is the iterative scheme of a Newton-Raphson method? Iterative scheme is xn plus 1 equal xn minus f of xn divided by f dash xn. Now, as we know that in case of xn plus 1 to phi xn, if this iterative scheme, general iterative scheme, then if mod of phi dash x is less than 1 for all x belongs to I is a class interval in which our approximate real root or exact real root exists or lie. So if we compare this iterative scheme with this iterative scheme, what is the value of phi x? Phi x equal x minus f of x divided by f dash x. Now what is the value of phi dash x? Phi dash x equal 1 minus, this one is a f dash x into f dash x minus fx f double dash x divided by f dash x का whole square, f dash x का whole square. So if we simplify this one, and write in the form of a mod, means mod of phi dash x is less than 1. Mod of phi dash x is less than 1. If we simplify this, x become phi dash x become minus of x f double dash x divided by f dash x ka whole square. So what is the condition? Condition is a mod of phi dash x, this to be less than 1 for all values of x belongs to I. Now if we simplify this one, then mod of fx into f double dash x must be less than x belongs to I is a class interval where any approximate root or our actual root exists. So this one is a what? This one is a criteria for convergence. Criteria for convergence to choose correct initial value. This one is a what? This one is a criteria for convergence. So this one is a criteria for convergence. Now we try to solve some numerical example based on a Newton-Raphson method. So first we solve an algebraic equation with the help of a Newton-Raphson method. So and many more we try to solve many more problems based on a Newton-Raphson methods. So first we consider, suppose fx equal what? fx equal 2x cube minus 3x plus 6. So what is the iterative scheme? So there is a need of a what? Example based on a what? Newton-Raphson method. Example based on Newton-Raphson method. Newton-Raphson method. Newton-Raphson method. So there is a need to find out the value of f dash x. F dash x is a what? 6x square minus 3. And what is the value of f double dash x? F double dash x is a what? 12x. 12x. So this one is the value of fx, f dash x and f double dash x. Now what is the iterative scheme? Iterative scheme become xn plus 1 equal xn minus f of xn divided by f dash xn. F dash xn. Now what is the xn? Here f of xn. So if we write here xn plus 1 equal xn minus f of xn is a what? 2 times of here we put in place of a xn we write xn 2xn cube minus 3xn plus 6 divided by f dash xn means 6 xn in place of x, here we write xn 6xn square minus 3. So if we simplify this one become what? If we multiply this one 6xn cube, this one minus 3xn, this minus become minus 2xn cube plus 3xn minus 6 divided by what? Divided by 6xn square minus 3. 6xn square minus 3. This one is xn plus 1. xn plus 1. Now, if we simplify this one, now iterative scheme for this problem become what? xn plus 1 equal 6xn cube minus 2xn cube. This become 4xn cube. 4xn cube minus 3xn plus 3xn cancel out. This one minus 6 divided by 6xn square. 6xn square minus 3. 6xn square minus 3. So this one is a iterative scheme for this problem. Now how we choose the value of x0? Question is how we choose the value of x0 which satisfy the criteria for convergence. So if we for this one we try to find out the one interval where at least one there is a 3 real root. So at least one real root lie between that interval. So suppose at x equal to 0. X equal to 0, what is the value of this one? F of 0 equal to what? 6. X equal 1 is a what? F of 1. This become 2 minus 3. 2 minus 3 plus 6. This one equal what? 2 minus 3 plus 6. This one equal also means 5. This one is also a positive value. X equal 2. Then f of 2 equal 16. 16 minus 6. 6 plus 6. Sorry, this one is a minus 6, otherwise you are able to find out the root. So this one is a minus 6. So this one is a minus 6, so this become minus 6. This one is a minus 6, and then this become what? This become plus 6. So this become plus 6, so this one is a plus 6. So this become plus 6, so f of 0, this one is a negative, means a minus 6. Negative value. At x equal to 1, f of 1 become what? f of 1 become 2 minus 3 minus 6. This one is a what? 9. This one is a minus 7. At x equal to 2, f of 2 become 16 minus 6. And this one become minus 6. This one is a what? 12. So here one negative value and one positive value. What is the meaning of this one? One root lie between 1 and 2. One root lie between 1 and 2. Now, what value we choose between 1 and 2 as the initial value? So for this one, what is the criteria for convergence? Criteria for convergence is what? Mod of fx into f double dash x must be less than f dash x ka whole square. F dash x ka whole square. So what is the value for if we choose x equal to 0? X equal to 2. Sorry. X equal to, what is the value? 16. 8 to the 16. 6 minus 6, 12. 16 minus 12, this one is a 4. So 4 into 24, this one less than what? F dash x. F dash 2. What is the value of f dash 2? F dash 2, if we find the f dash 2, f dash 2, this one is a 6 into 4 minus 3. This one is a 24 minus 3. This one is a what? 21. So this one is a 21 ka square. So this condition is true. So we start our iteration with the initial value x equal to 2 in this iterative scheme. Now we start our iterative scheme. Because at x equal to 2, the criteria for convergence satisfy at x equal to 2 for this iterative scheme, for this function. So we start from x0 equal to 2. So if n equal to 0, then what is the value of x1? x1 equal 4 plus 6 divided by 6 into 2 square minus 3. This one 2 to the power 3 is 8. This one is a 32 plus 6 divided by this one is a 21. So this one is a 38 divided by 21. So now what is the value for x1? Now I think this one is the correct value. So 1.80954. Similarly, if you find the x2 equal 4x1 cube plus 6 divided by 6x1 square minus 3. So we put the value of x1 here. We put the value of x1 here. X1 here. Then be able to find out the value of what? Then be able to find out the value of x2. x2 equal what? x2 equal 4 x1 means 1.80954 the whole cube plus 6 divided by 6 x1 means 1.80954 square minus 3. If we simplify this one, already we noted down the value of this one 1.7842. Similarly, we find the value of x3, x4, x5 and so on. When we stop this iteration, we stop this iteration if we try to find out the root is correct up to 1 decimal places. If the root is repeated up to 1 decimal places in 2 successive iterations, then we stop this iteration. If we try to find out the correct up to 3 decimal places, if in a 2 successive iteration, if the values after 3 decimal places repeated, then we stop this iterative procedure to find out the root correct up to 3 decimal places. Here we write down the values of x0 is a 2, means then the value of x1 is a 1.80954. Similarly, if we find the x2, then 1.78420, x3 equal 1.783769, x4 equal 1.783769. So here this one is a what? In a 4 iteration, we able to find out the what? We able to find out the root which one is correct up to 5 decimal places. So this one is one algebraic equation, means how we find the solution of algebraic equation with the help of a Newton-Raphson method. Now we solve one another example with the help of a Newton-Raphson method. So what is the here if we try to find out the reciprocal of any natural number, means we try to find out the reciprocal of any natural number. Suppose we denote this one as x equal 1 upon n. So here we write, this may be write also here n equal 1 upon x. You may also write this one is 1 upon x minus n. So suppose this one is a what? This one is a fx. This one is fx. So what is the value of f dash x? F dash x is what? Minus 1 upon x square. Now if we try to write the iterative scheme of by the Newton-Raphson method to find out the reciprocal of any natural number, means 1 upon n. So what is the iterative scheme? Xn plus 1 equal xn minus f of xn divided by f dash xn. F dash xn. Now if we write this here, xn plus 1 equal xn minus f of xn is a what? Minus f of xn is a 1 upon xn minus n divided by f dash xn minus of 1 upon xn square. So if we simplify this one, xn, after simplification we get this iterative scheme of xn to find out a reciprocal of a natural number. We try to find out the what? X equal 1 upon 90. This one is the what? 1 upon n. N is the what? 90. So iterative scheme is this one. N equal to 0, then x1 equal to x0, 2 minus n, x0. So 2 minus 90, this one is a x0. X0 is a what? X0 is a into 0.05. Now what is the value of x1? X1 become what? X1 become 0.525. 0.0525. This one is the value. Now what is the second value? Second value become what? X2 equal x1 minus 2 minus 90 into 0.525. Now x2 equal, in a similar manner, if we put the value of x1 here, x2 equal 0.0, this one is not a 0, this one is a 0.0525 into 2 minus 90 into 0.525. If we simplify this one, then we find this result. So if we concentrate on here, what is the value of x0? X0 is a 0.05. x1 is a what? 0.525. x2 is a 0.52631. This one is a 52631. not a 52631. I think this one is a what? This one is a 0.05231. This one is a 0.05231. So this one is a value. This one is a value of a what? 1 by 19 with the help of a what? With the help of a Newton-Raphson method. Any numbers, any natural number. Suppose x equal what? We try to find out under root 5, or x equal any root of any number. Okay? Root of any number. Then what will happen here? What is the iterative scheme? X square become what? X square become capital N. Then fx equal what? Fx equal x square minus n. What is the f dash x? F dash x become 2x. Now what is the iterative scheme? What is the Newton-Raphson iterative scheme of by the Newton-Raphson method? Xn plus 1 equal xn minus f of xn divided by f dash xn. F dash xn. Now, if we put the values here, xn plus 1 equal what? Xn means xn square minus f of xn is a xn square minus n divided by what? Divided by 2xn. If we simplify this one, what is the iterative scheme? First we take out this one. So what is the iterative scheme? So 2xn, here we multiply this one, 2xn square, xn plus 1 become what? 2xn square minus xn square plus n divided by what? Divided by 2xn. So this one is a what? 2, this 2xn square minus xn square, this one is a what? Xn square. Xn square plus n divided by what? 2xn. So this one is a iterative scheme. You may also write a more simplified form. This one is xn plus 1 equal 1 by 2 outside. Inside this become xn plus n divided by xn. This one is a what? This one is a iterative scheme to find out the root of any number. Suppose we try to find out the root of a 5. So if we start from n equal to 0, then what is the value of x1? x1 equal 1 by 2 x0 plus x0 means x0, n is a what? N is a 5. 5 divided by x0. So if we choose the value of x0, suppose we choose the x0 equal to 2. x0 equal to 2. So x0 is a 2, then x1 equal what? x1 equal 1 by 2 x0 is a 2 plus 5 by 2. 2 plus 5 by 2 means that this one is a 4 point, this one is a 2.5 plus 2, 4.5 divided by 2. What is the value? This one is a 2.25. x1 is a 2.25. Similarly, we find the x2 equal, here we put n equal to 1, x2 equal 1 by 2 x1 plus n by x1. Means here we put 2.25. Here already we noted down the values of if x0 with a 2, then x1 is about 2.25, x2 is about 2.2361, x3 is about 2.23606, x4 is about 2.3606. So in this way, we able to find out the root of any number with the help of a Newton-Raphson method. So these are some examples that we have discussed how we solve with the help of a Newton-Raphson method. Means how we solve an algebraic equation with the help of a Newton-Raphson method. How we find the reciprocal of any natural number, means how we find the 1 upon n, and how we find the root of any number, any natural number with the help of a Newton-Raphson method.